You know, the ground beneath our feet feels pretty solid, right? Doesn't it? But what if I told you it's not solid at all? It's actually a bunch of gigantic puzzle pieces constantly on the move. Today, we're diving into what happens when those pieces grind, slip, and snap, creating one of the most powerful forces on Earth, an earthquake.
Okay, right off the bat, let's get one thing straight because it's the most important piece of this whole puzzle. Earthquakes are not random. They don't just happen anywhere, anytime. There's a pattern to them, a logic that's literally built into the structure of our planet. And that, of course, leads to the big question, right? If they aren't just random acts of nature, then what's the deal? What hidden blueprint decides where the ground is going to shake violently? Well, let's find out. To start, we've got to look at a world map, but not a map of countries. We need to look at a map of where the planet is the most active. We're on the hunt for Earth's unquiet belts.
So, when you actually map out where earthquakes happen, this incredible pattern just jumps out at you. You see these distinct lines, these clusters. They light up places like Japan, Indonesia. They run all the way down the west coast of North and South America. This is no coincidence. It's a massive horseshoe-shaped zone of chaos called the Ring of Fire, and it basically traces the edges of the giant Pacific tectonic plate.
Okay, so we've got the where figured out. Now we have to go deeper, literally, to understand the why. We need to talk about the unbelievable, invisible forces that are building up pressure right under our feet at this very moment. And really, it all boils down to just three types of stress. Think about it like this. You've got compression, which is a squeezing force, tension, which is a pulling apart force, and then shear, which is when things slide past each other. These exact same forces are constantly at work on those massive tectonic plates, squeezing them, stretching them, and grinding them, storing up incredible amounts of energy, sometimes for hundreds of years. And this right here, this is one of the most intense places where these forces go to work. It's called a subduction zone. You're looking at a huge, dense oceanic plate literally diving and grinding underneath a continental plate. It's a colossal, slow-motion collision driven by compression. The friction between them is immense, and the stress just builds and builds and builds to absolutely unimaginable levels. For a long, long time, the rock holds. It resists. But nothing can withstand that much pressure forever. Eventually, it hits a breaking point. So let's look at what happens in that sudden, incredibly violent moment of release. That break, that's the earthquake. It's the snap. The rupture begins at a point deep underground called the hypocenter. And from that one spot, all that pent-up energy explodes outward in the form of powerful seismic waves. The point on the surface directly above that break is the epicenter. And that's usually where the shaking is the absolute worst. And the immediate result of all of that energy hitting the surface can be just devastating. The ground itself can literally rip open. The shaking can trigger huge landslides. Buildings, of course, can crumble. And then there's a wild phenomenon called liquefaction, where soil with a lot of water in it basically turns to quicksand. That's what caused so much damage in the massive 1964 Alaska earthquake. But sometimes, the biggest danger of all is the one that's born out in the ocean. When one of these massive earthquakes happens at a subduction zone, the plate on top can snap upwards, violently shoving a gigantic column of water with it. I mean, we are talking about a section of the ocean floor, maybe hundreds of kilometers long, being thrust upwards by 4 or 5 meters in an instant. All of that displaced water, all of that energy, it has to go somewhere. And that energy is what creates a tsunami. To really, truly understand the terrifying scale we're talking about, we have to look at one of the worst examples in modern history, the 2004 Indian Ocean tsunami. So on December 26, 2004, a monster earthquake ruptured the seafloor just off the coast of Sumatra, Indonesia. And what this map shows is just how massive the fallout was. This wasn't a local disaster. The wave energy radiated across the entire Indian Ocean, eventually hitting the coast of Africa thousands of kilometers away. The human toll was just staggering. In Indonesia alone, the country closest to the quake, more than 167,000 people were killed or went missing. Just let that number sink in for a second. These images show the city of Banda Aceh. The force of the water is it's hard to even comprehend. Entire neighborhoods, whole landscapes were just erased from the map, leaving behind total and complete devastation. This is the terrifying ultimate power of an earthquake that happens under the sea. So let's pull back for a moment from this one horrifying event to the bigger idea. Because moments like this, as catastrophic as they aren't some kind of fluke. They are a fundamental, unavoidable part of living on a planet that is alive and constantly changing. And this really is the main takeaway. What we feel as a sudden, violent earthquake is actually the climax of a story that's been unfolding slowly and relentlessly for millions of years. It's the steady, constant grinding of continents that builds the pressure for these sudden, awful moments that can, literally in an instant, reshape our world.
And that kind of leaves us with one last thing to think about. Those forces we just talked about, they're still at work, right now. The continents are still moving. So if our world is constantly being redrawn, what do you think it's going to look like in another million years?